Hello and welcome to the closing session of our course in which we actually write code. I would like to take you back to our application behavior session in which, as you remember, we've written all this code. I copied the subroutine here and I named it Extract Annual Trading 2. I will briefly remind you what we did. We had a master workbook template that had a lot of transactions. We opened it and then we created a new workbook. We called it 2012 Trading. We copied the first worksheet with the transactions to the newly created workbook. And then we called a function that removed rows that their annual year was beyond the trading annual year we defined here in this constant. And then we saved the new workbook and we closed everything. We also used a few of the application behavior flags, such as screen updating, we turned it off, and the calculation, we turned it into a manual mode. And we also used the status bar so that we can notify the user down here of the progress of our activities. All that is very well. Now let's consider the situation in which we run into an error during runtime. For example, let's say that we have somehow provided a wrong file name. I'm adding an X to this file name here, and this file doesn't exist. And we accidentally provided that to the open workbook open method that you see here. And since the file does not exist, an error will be raised by the application. Let's see actually what happens. I'm pressing F5 to run this subroutine. And as you can see, we received an error from the Excel system that this file cannot be found. Now think about the user that is working with a beautiful application, and all of a sudden he's encountered with this ugly and unclear dialog box with a runtime error with the code. Maybe this is not clear, he doesn't understand what does it really mean. He has some options here, some buttons. He doesn't really understand what is the meaning and what he is expected to actually press. If he accidentally click debug, which is the default button, so a press of the enter key will take him straight to the code, to the VBA code, which is something that we definitely don't want the end user to do. Let's close this dialog box. Something else that happened, since the error was raised in this statement, we are currently in a situation where the calculation mode is set to manual. The status bar has a message down here. You can see preparing the annual trading. This status is now stuck to the user. We are returning control back to the user with this status bar not clean, with the calculation mode in manual mode. Let's see that. I will use the immediate window to ask for the value of the calculation property. This is the code that is currently set. Actually, if we ask to see what is the value of the calculation manual setting, you can see that it is exactly that minus 4135. So we are leaving the state of the application in a fragile state, and we do not want to return control to the user before we took care to restore the state back to what it should be. So these are two major issues we want to avoid. What we really want to do here is that whenever an error occurs, instead of passing the control to handle this error to the Excel application, we would like to intervene and capture that error ourselves and handle it the way we see fit. How do we do that? Right here, before we actually call the open method of the workbooks, which is susceptible for an error because it depends on a value that we don't know where it came from. Maybe a user entered a file name, or maybe the file was actually deleted from the hard drive We don't know. Maybe someone changed the mapping of the drive, the network drive. Something could have happened externally. So just before we call that method, we would like to say that whenever an error event is going to happen from this point on error, what do we want to do? We want to go to an error handler section that we will add in our subroutine. We will call it, in this instance, failed open file. And as you remember, we can do a go to a section, and let's, at the end of the subroutine, add this label. So we are jumping right here. And what do we want to do when we fail to open the file? We would like to notify the user with a message box that we have full control on. And here, to save us some time, I already prepared the message box call for us. The message is failed to open and process the external workbook, and we also provide the file name that we have that will help him try to track where that file is. And please make sure the file exists. We close the line here, so carriage return line feed character will cause a new line in the message box to be inserted, and then we also provide the error description that was given by the error that was captured. So whenever an error is raised, we have an object called ERR that has some nice properties like error code and error description. So we use the description property to display that to the user, so we'll have some more technical information that may help him resolve the issue. And that is in addition to the nice message that we have constructed for him, of course. So we provide him a lot of information. And as usual, we have only one button, an OK button to close the dialog box, and an exclamation icon, and a title for that message box dialog box. So what happens if an error occurs? We jump right here. We provide the message box and the subroutine ends. Let's see how this behaves. F5, and as you can see, we have the dialog box that we have constructed with the OK button only, with the nice message that we have constructed for the user that includes the full path and file name. You can see that with that X, that file probably doesn't exist. And we also provide the full description given by the system. And let's close that dialog box. Now, we have still not catered for the problem that all of these flags were not turned off. So the status bar is still turned on, and the calculation is still in manual mode, etc. So in order to make sure that we always do that, what we do is we defined a new label to enclose the closing section. I call it usually close sub, colon. And right after we display the message box within the error handler, we jump to the close sub section. So what's going to happen? The message box is going to display to the user, and then control is being routed to this section, which actually takes care of restoring the state back to what it was before. Let's see what that change had made to our function. So F5, we receive the error message, we press OK, and we have an error. Object variable or with block variable not set. Let's see what happened. I'm going in debug mode to where that error was raised. And as you can see, we here in the closing section, we attempt to close a workbook object that does not exist because we failed in opening the master workbook. So this statement never really occurred. So we never really set this object to point to anything. So when we attempt to close nothing, we fail, of course, and Excel raises an error. You must be thinking, well, we probably need another error handler within the close book. That could be an option, but I suggest something else. We don't really need to bother the user or make our code flow more cumbersome in handling this error. What we simply can do here is check if this object is actually set to something meaningful. If yes, we close it. If not, we don't. So what can we do here? We can ask, if not, workbook trading master is nothing, then we actually close it. So here is a test. If this object is nothing, meaning it was just dimensioned here, but it was never set to any value, so it's nothing by default. If it is nothing, then this not will flip it to be false, and then this will be skipped. So we are not closing the nothing object. However, if this is not nothing, then all of this turns back to true, and we actually close the workbook. So that's a good resolution for this situation. And of course, all of these always happen. So let's run and see the effect of this latest change. F5, we have the dialog box, I close, and I have this error popping again. Why is this? And again, and again. In a loop, an endless loop of raising that message box. I press the control break to interrupt the code myself, to get out of the loop. And let's see why this happened. We had an error raised here. We jumped to the failed open. We displayed the message box to the user. We jumped to the close sub. We performed all of these actions. The code continues to run, and oops, the message box is being opened again. And then we close it, we jump back to close sub, and everything happens again in a loop. So what we need to do, and this is most important when we handle errors in our subroutines or functions, is to make sure to exit the subroutine or exit function or exit sub, depending on whether this is a sub or a function, just before the error handling sections. So if we have an error raised, we jump right here, we perform all of these statements once, we jump to the close subsection, we process the closing activities, and that's it. We exit the subroutine before we handle the error again. And if no error was ever raised, we never really want to go into this section anyway. So if this subroutine has no errors, we have a sequential run of all of the statements right up to the exit sub, which terminates the subroutine before going into processing any of the error handlers. Let's add another event, since here we are attempting to save the file. As you can see, we are saving this file, and again, we cannot anticipate all of the possible situations that may occur when we address the hard drive or folders or files. So we want to make sure in these cases that we take control in case of an error happening. So just before that, I will call again the on error, go to failed saving file. This time I will call this label, and I'm just adding another error handler, actually, right here in the end, that surely will go to close sub after I do whatever it is I want to do. What I want to do is just display a suitable message to the user. Here I copied this message for us to save us some time. And always I'm jumping back to the close sub to clean up and return control to the user with a clean state. So I'm restoring the states. By the way, you can write a generic function or a subroutine called maybe restore state, and have this in this restore state always, and just call the restore state function here every time instead of repeating these three statements in every subroutine or function. That's what I do in my projects usually. There's one more thing that we need to take care. As you see here, we are turning the display alerts off just before we're saving the file. We need to make sure that we always turn it back on before we return control to the user, even if an error was raised here. So in the close subsection, first I make sure that I turn the display alerts back on. So if there was no error raised, I turn it off, I save the file, I close it, and I restore display alerts back to true. If an error was raised here, it is currently false. I will handle the error here, go back to close sub, and I will take care to raise it back to true. So it's my responsibility to return the control clean to the user. Let's examine some other useful tricks we can do with the on error. I have written a function here that is called isWorkbookOpen. It received a string with the name of the workbook, and it should return true if the workbook is open and false if the workbook is not open currently, and then we may want to open it ourselves or notify the user or whatever. Let's call this function to see how it works. So call isWorkbookOpen. I'm passing the workbook name to it, and we have a subscript out of range error. Why? Because this workbook is not open, and we have attempted to set our workbook object to point to this workbook. Sure, if we had a built-in function provided by the VBA object or Excel to check if a workbook is open, we would not need to actually access this workbook and depend on the fact that it is open. But we don't have. So our trick to check if this workbook is open is by setting the object to point to this item. And if there is an error raised by this statement, we know that this workbook is not open. If there is no error raised here, then this will be performed and this workbook object will be pointing to a real object. I'm stopping the debugger. So what we can do in this case is call the on error resume next statement. What this does actually is telling Excel to just keep on and resume processing our code even if an error was raised. So just ignore the error, and we need to turn off this state by using the on error go to 0. So this terminates the on error resume next state, and errors will be raised normally beyond this statement. So what are we doing here? We are telling Excel, if you encounter an error here, just ignore it and keep on running the program. And here is the trick. If we actually succeeded in setting this workbook object so it is not nothing, we know that this workbook is actually open. So we can return true from the function. If we failed, this workbook object remained nothing, so this will return false, and we will return false from our function. So we're actually using the fact that there is an error raised here to our benefit. We're really making use of this error without interfering with the user. Let's see how we can use this function in context. For example, so I have prepared a short subroutine to do that. I'm setting the book name to whatever I want, and I'm calling the function right here. If it is open, then I can use it here in this area. I can do whatever I want with this open workbook. However, if it is not open, then I can do whatever I want, maybe open it myself, notify the user, or whatever. So if we want to write robust, good applications, we must handle the errors, especially when we access external resources on which we don't have much control on. As we've seen, whenever we ask for files, whenever we ask for system data, whenever we access the internet, maybe there's no connection, maybe the website or the service we access is not functioning currently. Whenever we do something with a resource that is beyond our control, we must handle it accordingly with the own error statement. I would go on and say that a robust and good application always handles errors regardless. So there could be errors, runtime errors, that you haven't thought of that may actually happen at the customer, and you failed to capture yourself. And you didn't think about this situation, and something happened, and so all of a sudden the user receives an error message by the system with all of the disadvantages of that, as we've seen earlier. So good programming is actually always handling errors, and it is advisable that you start embedding error handling as part of your routine programming practices. Thank you for attending this session and this course. I hope you gained a lot. We will close the session and summarize the whole course shortly. See you then.